A differential equation is an equation that is the derivative of something else, right? It's something that's of the form dy dx equals g of x f of y. And this can be a bit confusing, but ultimately there are relationships in the equation such that we should be able to find the equation this came from, or in other words, the solution to a differential equation, or diff EQ, is another function. And since the equation you're looking at is the derivative of something, then it should make some sense that we're going to be using integration to find our solution, our original function, so to speak. Now, let's look at this by way of example. We have got a relationship, dw dt is 1/25 times w minus 300. So the derivative of w, whatever it is, with respect to t, is 1/25 w minus 300. This is our differential equation. And we're going to be told some specific things about the original function, specifically that w of 0 equals 1400. Right? And what this means in terms of our original equation is that when t equals 0, w equals 1400. That's the one piece of information we know about the original equation, right? And so this is specifically called an initial value. And it's this information that lets us ultimately define what the original function is. So before we start dealing with this, consider a couple things. If I'm told that dy dx equals 2x, well, by integration what I know is that y equals x squared plus c. And the one thing I don't know is I don't know what this c is, right? It could have been that x came from x squared plus 3, or it could have come from x squared minus 5, or any number of things, that constant. And it's that initial value that helps me determine what specific function was I starting with, right? So, just to get ourselves some more room, again, dw dt equals 1/25 times w minus 300, and we do have this initial value. We're told that w of 0 equals 1400. Okay? Anytime you're asked to solve a differential equation, the first thing you must do is separate the variables. And what I mean by that is get everything with w on both sides and everything with t on the other side. And so let's just deal with the left-hand side first. I'm going to multiply both sides of this equation by dt, which means that dw equals 1/25 times w minus 300 times dt. Right, so I've begun to separate the variables, and the way this sets up is I'm going to want my things with w on the left and my things with t's on the right. Now, I do have this w minus 300 on the right, and that needs to move, so I'm going to need to divide both sides by w minus 300. I'll write it this way: 1 over w minus 300 dw equals 1/25 dt. Now that we've separated the variables, our next step is to integrate both sides. So I'm going to be taking the integral of 1 over w minus 300 dw. So the left-hand side I'll be integrating with respect to w, and the right-hand side 1/25 dt, so I'll be integrating with respect to t. When I integrate on the left, I get the natural log of the absolute value of w minus 300, and since I integrated and it was indefinite, I've got some constant, call it little c, and that's going to equal 1/25 t, and that's also with some constant, and I'm going to call this little d. Now I've integrated both sides, and I've got constants on both sides, and it should make sense that if I subtract one constant over to the other side, then their sum will be some other constant. And so in terms of your work, ultimately what you need to show is not the constants on both sides, but that you've got a single constant on one side. Right? That would be the combination of the two, and we'll write this as plus big C. It's very important that this right after you integrate, you always bring in plus C, plus that constant. Right? That must be there every time. Now that I've got plus C, I can use my initial value, that w of 0 equals 1400, so that I can solve for the constant. Remember what that meant is that meant that when t was 0, w was 1400. So when I solve for C, when t is 0, I'll have the natural log of 1100, because 1400 minus 300 is 1100, equals C, because 1/25 times 0 is 0. I know the value of the constant. So, by substitution, I'm now working with the natural log of w minus 300 equals 1/25 1/25 t plus the natural log of 1100. I'm done when I have a function w in terms of t, so I'll be finished once I solve this equation for w. To get rid of this natural log, I'm going to raise both sides of the equation to e. So this will be raise them both to e. So this will be e to the natural log of w minus 300 equals e to the 1/25 t plus the natural log of 1100. Now it's expected that you're comfortable with this use of e, and if you haven't done a lot of work with this, you really need to spend some time going back and reviewing this. I'm going to continue my work up top where I have enough space. So on the left-hand side, e to a natural log of something is always the argument. Right? W minus 300 is called the argument. So the left-hand side just becomes w minus 300. The right-hand side, what we need to consider is just the exponent properties. So when I'm adding exponents, that comes from multiplying things with the same base. So this is e to the 1/25 t times e to the natural log of 1100. And e to the natural log of 1100 is using that property again, where e to a natural log is always just equal to the argument. So this will become 1100, because that's what e to the natural log of 1100 is, e to the 1/25 t. When I add 300 to both sides, I've got my final equation, or the solution to this differential equation, 1100 e to the 1/25 t plus 300. and this is the specific solution to my original differential equation that had the initial condition when t was 0. W was 1400. Again, let's review our steps. 1. Separate the variables. Ultimately, in our case it was dw dt. I'm multiplying both sides by dt, which means my t's will need to be on the right and my w's will need to be on the left. Second, integrate. After you integrate, do not forget plus c. Third, solve for c. Right? Once you solve for c, fourth, solve for the function.